and Cheryl Carmona, who is a co-manager of the Boone Street Community Farm, as well as a candidate for a Master's in Soil Science at the University of Maryland.
Sorry, my voice is not, so just give me a signal if you can't hear me, and I'll really try to project. I work at Boone Street Farm, and my background is in environmental soil science. I'm still working on a degree at the University of Maryland in the environmental soil science field. I studied poultry manure as a fertilizer and the environmental effects of poultry manure as a fertilizer for agricultural soils. So, but today I'm going to be talking about building healthy soils in urban environments, and I'm going to be talking about the characteristics of soils that we can recognize and look at that we want to potentially modify, because in urban soils these characteristics tend to be different than in agricultural soils. Okay, so I'm going to be going over giving an introduction to urban soil formation and just looking at how urban soils are formed. Then I'm going to be going over soil pH and plant health and how urban soil pH can impact growing our healthy gardens. And then I'll be talking about soil compaction and plant health and how urban soils have issues with soil compaction. And then we'll take questions at the panel. So this here is an image of an urban environment, and our soils lie beneath these structures. You can flip. And so typical soil formation in urban environments starts like this. In urban environments, when we're building or constructing structures, the first step is to excavate the land and build your foundation. So the natural soil that may have once been there, or the other soil that was put there, is removed from the land. We put down our foundation, and deconstruction. This is actually an example that I got to see about a month ago on 20th Street between Barclay and Greenmount. They were deconstructing almost an entire block, and I was able to see the whole entire process of going from having some row houses to a vacant lot that will eventually potentially have new buildings or new structures. And then on the other side of the street, they're going to be having a park. So I was able to watch the building come down. After the building comes down, you see this debris that's left there. This heavy machinery is then pulling away the debris. And then in this image here, you can see we're then excavating the foundation. So we're going back down about 4 to 5 feet below the surface of the soil. And you can see the debris on the sides of the walls there that tends to be left. So for a lot of community gardeners or gardeners who have worked in urban soils, you tend to find lots of bricks and cement and pieces of debris as you're gardening. And this is often how it happens. They're not perfect at taking out every last piece of debris that's left in the soil. So this is another image here. You can really see they've taken out the whole foundation. And then they come in and bring the fill material. What I've been told, and I haven't completely figured out the details about this, but when they bring in the fill material, the city has compaction levels that they're required to meet, depending on whether the land is going to be used to build more buildings or if it's going to be left vacant. So if it's going to be eventually holding more buildings, they compact the soil more. And if there's, I assume they're going to compact it less if it's going to be a green space. But the fill material is often subsoils that are coming from the county or from outside of the city. So fill material typically tends to be a very heavy clay that's imported into the city and becomes our urban soil. And so this is an image after, this is actually the other side of the street. So I think that they're actually going to be building here again. So I think that they just filled it in and left it that way. I'm not exactly sure, but it's just interesting to see. So natural soils have a completely different process, formation process. And I wanted to just show some soil profiles here. So these are, just imagine you take the soil and you cut it down, and you slice it down and go down about 3 feet. So these are images of the soil going down 3 feet, and you can see the horizonation. So this is a process that happens over thousands of years due to climate, hydrology, the parent material, the biological activity and the plant growth that's happening, and over time. So this is a typical soil profile of a Maryland soil. You can see these soils in Maryland tend to be very clayey. They're older, more weathered soils, and so the clay tends to stay closer to the surface, and other materials tend to leach down through the soil column and move through. And so probably this is why also as fill materials come in from outside of the city, they tend to be really heavy clay. And this is a typical Maryland soil that has a pretty heavy clay content. Urban soils are defined as a soil that has about more than 20 inches of mixing or filling from being excavated or contamination. So this is a nice soil profile here of an urban soil where you can see the abrupt line and the orange kind of coloration of the soil above the darker color. So you can see that a heavy clay material was brought in to fill in the land. Okay, so understanding now where our urban soils come from, I just wanted to talk about some of the challenges that gardeners or farmers have trying to grow healthy plants in these soils. So, the physical properties of the soils that typically tend to change when you have the urban soils forming in this way are, we tend to have much more compacted soils with much heavier clay content. This leads to a poor soil structure. It also leads to having more surface crusting, which is sort of like a hard layer on the surface, which makes it harder for rain to penetrate the surface. And it often leads to a higher soil temperature. And some of the chemical properties of urban soils that will change due to the process of urban soil formation are a higher variability in nutrient content. So these soils that are coming in as fill material over the past 50 years as things are constructed and deconstructed are coming from who knows where. There is probably little regulation on the fill material. I'm sure that they're not bringing in contaminated soils as much, but you end up with a much higher variability in urban landscapes. Often, if you look at a soils map, the entire map of the U.S. is, you can look and precisely see a land area and know the properties of your soil and what the soil looks like and the name of your soil. But in urban settings, often those maps are not filled in and left blank because these soils are so variable and they have not been mapped out. So you also have a low soil organic matter, low soil fertility, and high pH. Okay, so I'm going to be talking about soil compaction and pH because those are two really important properties that can really impact plant health. Obviously, the lack of biological activity in urban soils also really presses on people to, add organic matter and increase the levels of organic matter in your soil. I'm not going to talk about that tonight because I feel like that does get talked about a lot. So I'm going to stick with compaction and pH. So this is a nice image here to show a compacted soil and a healthy soil, and just how different the root growth is. So these are all impacts on plant health and environmental health due to soil compaction. So you have reduced pore space, reduced water holding capacity, and destruction of soil structure. All of those things are going to reduce your crop yields, make it harder for your plants to grow. It also leads to surface crusting, increased nutrient pollution of your waterways, and increased sediment erosion, which are all environmental impacts. So how do we recognize we have compacted soils? You can look at your plants, and there are some, if you could show that image. I have an image here. So when you have like root crops, like carrots or beets, this is a forage radish, this is a radish. This splitting of the head there is actually a common impact of compacted soil when you're trying to grow a root crop in a compacted soil. You'll also see stunting of your root crops. You'll have shorter root crops. You'll potentially see stunting, and you'll also see potentially signs that would show nutrient deficiencies. So there's a lot of crossover when you're looking at plant health and you're trying to determine what the cause is. But I would say seeing something like this would be a great indicator that you have compacted soils. You could also do something, if you are familiar with soils, you could take a soil probe or a knife or a sharp object, and you could feel this compaction when you enter the soil if you have a soil to compare it to that you know isn't compacted. Okay, so some management strategies to deal with soil compaction. Tillage and subsoiling. Subsoiling is a process you do with an instrument that literally goes down into the subsoil, and the recommendation is to go down 150% from wherever your level of compaction, where it starts. So if you're going down, if you're compacted down to 10 inches, you want to try to subsoil down 15 inches. So it's an instrument you use to loosen up the soil, essentially, and help to create air spaces, because compaction is essentially a loss of your soil pores. Tillage can also help with this. You have to be careful because tillage can also sometimes only get onto the surface and not get down far enough. And tillage is something I would recommend for, the first year or second year that you're trying to get into your soil and reduce the compaction, but it might not be something you have to do every year beyond that. It might be something you do to just get your soil to start to increase the pore spaces in your soil and help to build the health, but it might not be something you have to do every year. Okay. And managing traffic is another important point. If you already have compacted soils, you really want to make sure you have great walkways, so that you're not walking on your soils and just further compacting your soil. So elevated soil pH often can lead to micronutrient deficiencies and phosphorus deficiencies. So this chart here will show the top 3 nutrients are macronutrients. Those are the ones that your plants need the most of. And phosphorus, you can see, so an elevated soil pH is anything above, or an alkaline soil is considered anything above 7.0. So above 7.5, between 7.5 and 8.5, you can see that it becomes harder, and this is showing nutrient availability to plants. So it makes it harder for plants to absorb phosphorus when you have a higher pH level. I'm not going to get into the micronutrients here, but you can also end up having micronutrient deficiencies. You can see that the lines get much thinner as you get higher in soil pH. So, but phosphorus is a big one because it's a macronutrient and the plant needs a lot of phosphorus. Okay, so some management strategies for elevated soil pH. And I also mentioned that elevated soil pH is often due to the large amount of cement that we have in urban settings, and as deconstruction happens, cement breaks down and it adds a lot of calcium to the soil. So some management strategies. Compost will help to neutralize your soil pH. So it'll help to bring it down closer to 6.5, 7. So anecdotally, I'll say I know a lot of people who have high soil pHs in the range of 7.5 to 8.2. So using compost will help to bring the soil pH down. Elemental sulfur, and there's also iron sulfate, are amendments you can use. And I'm going to have a form up here about modifying soil pH that's available. Well, you guys can look at. I actually didn't make photocopies of this one. So if you want to look at the numbers, you can see what the necessary amounts you need to amend your soil. And then there are also some other small things you can do. You could use sawdust as a mulch. That does help to acidify your soil slowly. I have to say that modifying soil pH is something that takes time, and you have to give it time. So elemental sulfur, you have to amend it about a year before you want to see the impact. So this is something that takes time. And I also wanted to mention that it's important to also know what your lead levels are, because lead becomes less available the higher the pH of your soil. So it's another thing to consider as you are modifying your soil pH. If you know that you have, even if it's below the EPA limit, there's still lead there. So you want to be aware of that, and you want to work on bringing your soil pH down slowly, just so that you don't make the lead really available that first year that you bring the soil pH down. So another really important tip is to choose crops that are happy in the soil pH that you have. Okay, and so I have a handout up here that has a list of crops and the pH that they are happy at. And these are just a few examples. So crops that prefer acidic soil are blueberries and huckleberries, potatoes, and rosemary. I learned this the hard way last year because we tried to grow potatoes in very alkaline soil, and our potatoes did not do well. And then crops that prefer more alkaline soils are garlic, leeks, and asparagus, ginger, are just some examples. So I'll have a list up here that you guys can grab. So how do you know if you have an elevated soil pH? All of the soil testing labs, so on the back of the sheet that has the soil pH the soil pH levels that crops are happy at, I have a list of all the soil testing labs in the region, and all of the labs will measure pH along with nutrient levels and contaminant levels. So that's one simple way to quickly find out what your soil pH is. You could also, there are some home test kits that you can buy, so you can also do that. Okay, I think I'm very close. Yes, okay. Cool.